Hello, today I want us to carry out finite element analysis of this assembly that is made of three parts, and the purpose is to determine the maximum displacement and volumetric stress. You can see this image shows the displacement, and this one is the deformed one, and this section shows the undeformed. I'm going to illustrate how to generate such an image. And the analysis we're going to perform, we'll have this bracket here. These holes to be fixed. We're going to fix these holes. It's like bolted. Then we're going to apply force on this face. Let me use a trimming snipping here. I'm going to assume there's a cable that is here supporting a certain load. Therefore, this will be my force on these holes. There are two holes here. We're going to assume there's a cable, there's a load here at the center. Basically, we're going to assume there's a load here at the center, like that. Then you're going to fix this one here, fix this and fix this, and we are going to weld. We're going to connect this using welded joint here and weld here. We're going to use a fillet weld. Therefore, the first step is, let me first hide everything here. We need to connect these two using weld. And if you go to applications, you can see we have welding here, and these are the types of welding. We have fillet, we have groove. These are the types of groove. Then we have a plug, stroke, strut weld, or a spot. For now, we're going to focus on the most commonly used, that is a fillet weld. The first step is you select the fillet weld here, and there are two types of fillet weld. You can have double-sided or single-sided. Double-sided is whereby you weld this face and this face. Therefore, for this case, we're going to use double-sided, but for the single-sided, it's just here. You see? Therefore, if you select a single-sided here, for the location, we have the first face surface, this surface here, like that. Then the second one is here. Just select one. If you select one, it allows tangent propagation. Therefore, you can see we have a tag. Once you select one, it propagates even to the other section. You can see here. Therefore, if you select one, it allows tangent propagation. And this one defines the size. That is, we have to use 5 mm. You can see now it becomes bigger when I use 5 mm. That is a single-sided fillet weld. In case you have intermittent weld, whereby we have some breaks, you can select intermittency, but for now you leave this as unchecked. If you select here, you can select maybe intermittent here. You can use maybe a length of 50. If you select 50 there, oops, intermittent 50, you can see this becomes 50. Number of welds, therefore 1, 2, 3, and 4. If you increase this value, you can see the intermittent. That is in case you don't want to have a complete fillet weld. Next is options. For the weld geometry, this geometry can be a surface, can be light. You can see once I select light, see how it looks. But for me, I prefer, for FEA, I prefer selecting becoming a solid. And we can assign material, and this ones we can assign later material of this weld for us to perform accurate FEA. And then for the weld process, for now you can leave everything as none. For the finish, in case you are going to perform chipping, removing the excess material, grading or machining, rolling, but for now leave everything as none. Then for the, you don't need to define this for now. You can give the name you want here and say okay. Once I say okay, you can see my weld is formed, and the thickness of this weld is 5 mm. And you can see we have the saber here. Okay, therefore if you want to do some edit to the weld, like saber properties, you can just go here and edit. Okay, and next I want now to add weld between these two. I think our image has weld. You can see this one is weld. You can see this weld here. Therefore, for this one, just select fillet. But for this time around, select double-sided and go to location again. This is where you define the thickness, 5 mm. We have arrow side. For the arrow side, we usually have arrow side and other side for the double-sided. Therefore, you start by arrow side, this face, other side becomes this face. This is because you have to weld inside and outside at the same time. Go back for the arrow side, this face, for the other side, same face. Okay, for the arrow side, this face and this face. For the other side, you have to define both the arrow side and other side. It is like externally and internal, because you're going to weld. You can see you're going to weld here, that is a arrow side, and this side becomes other side. And for the options, again select solid and say okay. You can see now the weld here. Okay, you can see that. You can hide those symbols by selecting this one here. You see this icon, it is called annotation display. Turn on or off the read annotations and annotation elements. Just turn them off. That's the weld. If you can do a section view and see the weld, can see, yeah. Then you can close. We have defined the weld. Therefore, then in later we're going to tell the Creo simulator that this weld is forming the connection between this bracket and this bracket. This becomes a connection between this bracket and this bracket becomes a connection. There are so many types of connections. We have bolted connections, yeah, rivet connections. And for this is a weld. Then the next step is I want us to create a point here below, a point somewhere here. Remember we said the load will be applied at the center between these two holes. If your model is not symmetrical at any of the standard planes, you can create your own plane. You can just select plane here, then select this face, and say okay. And you can see this plane is now at the middle. We have a plane here. Let me open this, and maybe I can hide this. I want to hide these planes. Also, yeah, this is the plane I'm talking about. This plane is my, I can say, middle plane. Yeah, you can use a double underscore here middle plane like that. This is a plane that is passing through the it's like a symmetry plane for the assembly. Therefore, the load will be on this plane, our load. Therefore, I'm going to insert a point onto this plane. Therefore, I go to a point onto this plane. Then I want to use this edge as my reference and this edge is my reference. Basically, let me use this edge here. I'll just approximate like that. You can see now that's my point. If I go from this side here, you can see my point lies on the plane. Therefore, let me hide this. If I view from this side here, let me activate this point. You can see this point is at the middle of it is along the symmetry plane of the assembly. Therefore, this point is my load action point. Yeah. If you want to be more precise, depending on your depending on your model, you can just change here to 150. Maybe this to become 35. Okay, maybe we can let's see whether we can measure. Let's measure this distance from this edge to this. Let's see whether I can get that distance. Measure. Let's measure using this to this. I have to press control. You can see the center distance here is 35. Therefore, this is the center distance, that is 35, meaning my point has to be 35. You can see now the point is exactly passing through the center of this circle. This can be 100. Let me just go a little bit higher. You have to define the load action point. Okay. Next we go to now you have to assign material. We can assign material later under the analysis. We go to application, simulate, select simulate now. Here is where now we define our load, our displacement, and our weld. Go to the refine model first and let's go one by one. We need now to define the connection between the brackets, all these three brackets, this bracket, this and this. Therefore, you go to the review geometry. Let's first for review. You can see this means that these geometries are not connected. Therefore, let's go here. We have a fillet there. We have a fillet there. Therefore, let's first for define the weld. If you go to the weld here, let's first for define. We need to define not a perimeter, not a spot, but a weld feature that is existing, which is this. And we can overwrite here. We can give it material of magnesium, or you can change the material. You can select more here. If you go to the legacy, you can select the material you want to assign. Yes, but you want to for me, I want to assign this Mg, or I can assign high carbon steel also. Again, go to the weld. Another one here is go to weld. Select this one here, override and assign high carbon steel. Okay. If you now go to the review geometry and apply, you see now. Let me hide this. Let me hide. I want to hide. Okay. You see now this one's pink weld surfaces. You can see this one is a magenta. It is a weld surfaces here. You can see this one here, and yeah. Therefore, um, if you review your geometry, you are supposed to see, if you see apply, if you see this one represent a weld surface. Something here is not okay, because now they are saying it's a bordered surface. This one means these are bordered. Okay, let's first go back to the weld definition here and see location is defined well. Yeah, I think we have selected well. Let's just proceed and go back to the applications, go to simulate, and something happened here. We have to edit this here. Select this again. In case you get this error, you can fix it like that. Next is we need to assign material to these three brackets here. You can say edit material. But for now, I have material already selected here. You can see I have three materials selected. Therefore, we just need to create to assign material to the three parts. That is material assignment. For the material assignment, select this. Just select control this and this, three of them. I'm going to use steel. For the orientation, I don't need any orientation here. You can see how this symbol, these three symbols that show that represent material has been assigned. And if you go back here to review geometry, apply, you can see we have our weld. The surface means welded there. Then if you go to the autogen, there's autogen here to see the mesh or mesh, how mesh looks like. You can see you don't need to worry about refining the mesh, because the Creo parametric uses p-type of technology, whereby it increases the polynomial when converging. This means you don't need to get a finer mesh for you to get a precise result. You have to close this, close. No, that's how our mesh will look like. And then we need to assign, if you go home, this placement, we need to fix these holes. Therefore, if you go to the references here, I'm going to select a surface. I'm going to fix translation, fix these surfaces here. For the one, I can select individual, pressing control. This will be the mounting point. Therefore, we're going to assume we have fixed these three surfaces, four surfaces like that. And we need to have mass. We're going to assign mass at this point. Remember we said the mass is being hanged at this point. Therefore, if you go to refine model, we have two types of mass. We have mass and the mass properties. When you open here, you're going to see two. You just select mass. You can give it your name. For the type, we're going to use just a simple For the reference, I'm going to use a single point and select this point. Then for the value of that mass, I want to use kg. I want to use 50 kilograms of the mass at that point. Therefore, you can see this mass is here. And if you go to the load, you can see we have not yet defined the load. If you go to the idealizations, that is where you get the mass. This mass. Then we need not to say to connect this mass to these two holes. And in that case, we use a weighted link to create. We're just connecting this point to the holes using a link. We are going to assume this it's a cable is passing through these two holes that is supporting the mass. Therefore, if you select the weighted link, and I'm going to select this point, oops, sorry for that. You have to select independent side. Independent side is where we are mounting the cable, and the dependent side is the point. This is a dependent side on the bottom side here, dependent side. But for the independent, we're going to use single. You select this here. You have to press not the point. For the dependent side, we're not using the point, we're using a surface. Okay, sorry for that. You have to select a surface here and select this. You can see it selects both surfaces. This one here, can see, select both. If I remove all, if you select one, it is also selecting the other. You can see there are two, and say okay. For some reason, I don't know why it is not forming these types of link with the both holes, just forms with one. If I go back to the weighted link, let's try something else. Let me go here. If you change, out to try and see if I select edges, it will form these links for me. This and this. Let's see. You can see for the edges, it is forming these two links, but for the surfaces, it forms only one side. Let me see here. Go back to the surfaces. Let's add another edge. Let me see. Okay. But you see, in reality, the load is being supported by these surfaces. Therefore, have to use a surface. Let me see the intent like that. See, okay, you can see it is just forming one side, but I have already selected. It has selected both the surfaces. You can see, then from there, maybe for the purpose of demonstration, I can just use edges and select all these edges and assume my load is being supported by all those edges there. Okay, you can see. Now if I view from this side, this is a point whereby the mass is being hanged. And if you want to change the height of this, if you want this maybe mass to be a little bit lower, you can just go here to this point here, edit, and maybe change this value to 150. That is if you want. If I go back to simulate, you can see the value, the point at which the mass is acting on, you can vary it. The reason why this point is called dependent. This point is dependent. If I go back to the idealization here, connections, here on the weighted link and edit, you'll see not that for the mass here, edit. Okay, we have 50. 50 can still work. I'm looking for the, let me see what I'm looking for. This, yeah, I'm looking for this. Yeah, I was looking for this link. You can see this link is the point is my dependent, because I can be able to vary this one is depending on where it is being mounted on. This one is a independent. Therefore, we have assigned fixed, we have assigned material, and we have assigned weight. What is remaining? Gravity. Gravity is remaining because if you assign mass as 50, for us to get a force downward, we need to define gravity. And for the gravity, I'm going to assume is a 2g. You can say my z-axis is facing up, therefore I'm going to assume is negative. I'm going to use a 2g, 2 gravity. Let's preview 2 gravities. Let's preview and see. You can see this arrow facing up. This arrow is a preview. Therefore, I have to use a negative, negative, and preview facing down. Then say okay. You see now my gravity is 2g. We have a 2g. That is equivalent to 100 kgs here for the 2g. And we have assigned displacement. For the load we have assigned, we can also assign temperature load if you want. Constraints we have assigned, we can always assign a symmetry, but for now we can run the results. You go to the analysis and study the type of analysis. You can perform dynamic if you want, random, but for now is a static one here. For the output, I want stresses and reactions, rotations, nothing excluded, convergence. I just need a single pass instead of a multi-pass. I think for this one, I don't need quick check is not okay. I don't want to do a quick check, but for now, single pass is sufficient. Yeah, that you can run. Can say yes, yes. Okay, completed. Now you can be able to see your results. I just show one result, that is a displacement. For the display options, you can use deformed and overlay. Similar to this image, you can see overlay. Therefore, I want to overlay, and scaling I want to use just 10%. I can animate. Let me increase the frames here. Okay, and so yeah, I'll just show this displacement. You can see this color is kind of confusing a little bit. You go to format and edit. For the minimum here, let's have a 0. Then for this one here, I want to use glare, yeah, like that, for ease of okay. Again here, I'll change this to this. Okay, okay. You see now it is easier to see how this one is animating. You can see how it is deforming because we are calculating displacement. Yeah, that's the reason why you don't see any stresses around here. As you can see, the displacement maximum is 0.03 millimeters. If you want to go to the maybe stress and volumetrics, you can select here, and you can see the stress is around here. Yeah, but today I want us to focus only on the displacement magnitude. Yeah, you can see now how it's deforming. um if you don't want to see overlay and maybe you want to see these ones, you can see how they look like a pattern. You can select continuous tone to be continuous, and then if you want to see the elements of the mesh, you can just activate here. The quantity is displacement in millimeters here, and if you want to see on a maybe along z-axis, that is the same case as the it is deforming along z-axis. You can see, you can select component z-axis here and say okay. You can see now how the continuous tone look like. Yeah, when you select now z-axis, you get now reversed. You can see the red. Therefore, let me go to the quantity and say magnitude. You see now when I select the continuous tone here, um let me just edit, display, deselect this, continuous, deselect this, and say okay. Just see the continuous tone, how it looks like. That's how you can perform FEA of this bracket. Try this out, and if you have anything you want clarity from me, leave a comment in the comment section. Thank you, and stay tuned for more.